Now here we have a Vertex TRK-14. TR, tracking receiver, K, meaning that we expect KU band input. This tracking receiver has 4 different choices of input. They're normally pre-selected when you buy them. 11702, 11708.5, 12198, 12192. The idea here is that the satellites will generate a beacon frequency. So you choose the frequency that will match the satellite when you order this TRK-14. Gets input directly from the LNA, so it's getting KU band frequency, as you can see at the moment. It's looking at 12192 megahertz. The first understanding is that the satellite does not stay in a constant position. They can drift up to 1,000 kilometers. And when they do drift, the Earth station antenna has to be adjusted very slightly to stay on track. You can tell that there is a drift because the strength of the beacon frequency will decline or diminish. This device detects it. It passes an analog voltage to something like a Vertex 7200 antenna controller. The antenna controller modifies the position of the antenna, tweaking it slightly up, down, left, right, so that the signal strength comes back to where it should be. In addition to 4 preset frequencies, you can also generate your own frequency and input it here. This way you're not relying entirely on Vertex, as long as you have your own precise frequency. The other terminals on the back represent the output voltage that would be passed directly to the antenna control unit. Now I'm simulating the input from the satellite by using this frequency generator. I've set it to the same frequency that the TRK-14 is expecting, in this case 12192 megahertz. The input is low, and looking at the TRK-14, it shows that there is obviously an error, low signal, and the lock is not there. So what I'm going to do now, I'm going to increase the power and watch as this acquires what it considers to be the correct signal from the satellite. There, we've got to it now. So we're showing a neg 72 coming in, and we have a full lot. On the front, the output level is shown, and also on the meter next to it, you can see the voltage at 2.9. Now this is proportional. So as I continue to increase power, in other words, we're getting a better lock on that satellite. You can see the voltage that's being passed to the Vertex 7200 or other antenna controller is directing it. It's telling it that you're now on the satellite. The antenna controller, the sophisticated ones like Vertex 7200, work on a couple of different premises. One is that they have predictive tracking. They use a predictive tracking method. In other words, they know where the satellite should be. They draw an imaginary box around the orbit, and then they gradually decrease the box, moving the antenna, elevation and azimuth, until the signal increases. And this is the device that passes the increased signal to the antenna controller. There are several other tracking receivers. Some work in C-band, this one in KU band, and others works in L-band. So you need to choose the tracking receiver that's best for your application.